the book?
77.
177. Thank you. Thank you. Thank you. All right. So this talks about they have some data, and we're gonna have to use Desmos on this, which is fine. Actually, I can use these. Okay, so we talked about yesterday, started talking about the z-score, and we said a z-score is like a standard deviation. Agree? And basically the main difference between a z-score and a standard deviation, a z-score can be a decimal amount, and honestly a standard deviation can be a decimal amount. It's just that people don't like, for whatever reason. So they tell us on this particular problem that they said the average height is 69 inches and the standard deviation is 2.5. Okay? So this is just, they say average height of adult males in the United States. Now, friends, this can't be right. And I'm going to tell you why this can't be right. Notice what it says. It says the average height of adult males in the United States. You still following this? Is 69 inches. That's 5'9". That's my height. Friends, I swear, every male I come across is taller than me.
That's the new generation.
So there is no way the average height is 69. I mean, I have like 2 friends that are shorter than me. Everyone else is like a giant. So there's no, but that's what they claim. So unless there's like some states out there that have a whole bunch of, short guys, I don't think this could be right. But that's just my take. Okay, so does anyone remember what the z-score equation was? I know it's over standard deviation. What was it? Was it mean over observed? Was it that? I got 3-1. Got it? Almost there? Almost there? Yeah, right there. Left hand, that bottom, or right there.
Equals observation minus mean over.
Okay, so I went backwards. Observation, observed, minus the mean. Okay, so problem number 1, they talk about Jim Carrey, who is 74. They want to know what his z-score is. So I'm going to take the observed 74. I'm going to subtract the mean, and it's going to be over the standard deviation. So I'm just using a calculator here. So 74 minus 69 is 5. 5 divided by 2.5 is 2. So Jim Carrey has a z-score of 2, which means he is basically 2 standard deviations taller than the average male in the United States. And then it talks about old Shaq Daddy. Shaq is 85 inches tall. Now, I will tell you something. This was back in 1995, right before I started teaching. My dad, who is 6'2", and me, who is 5'9", I didn't get my dad's height. We went to Scottsdale Fashion Square, which is a nice mall in Arizona. And we are walking into the mall, and coming out of, because we didn't have streaming music, coming out of the music store where you could buy CDs was Shaquille O'Neal, all by himself. Oh my gosh. He's huge. And, he looks right at us. He's like, how you guys doing? He's like, hi, Shaq. He sticks his hand out, shakes my hand. I swear, my hand was like an infant hand. If his hand was the size of my hand was the size of my finger. It was like, he's huge. And he was just sitting there chatting with us a little bit. It was just the 3 of us. Like, no one realized it was Shaquille O'Neal. And then all of a sudden, people are like, oh my gosh, Shaquille O'Neal. He goes, have a nice day. It's good meeting you. And he goes walking out. And I kid you not, he gets into the smallest Honda Civic on the planet. I mean, I bet you he took the front seat out of the car and was sitting in the back seat. There's no way he could fit in that car. But needless to say, I met Shaquille O'Neal, which was kind of cool. So,
He's coming to Red Rock soon, the DJ.
oh, is he really?
Yeah. He did.
Oh my
Already
gosh.
did? Oh, never mind.
All right, so Shaquille, we're going to take his 85 minus the 69 divided by 2.5. So 85 minus 69 divided by 2.5. So he has a z-score of 3.08, which basically means he's over 3 standard deviations taller than the average person. That's crazy. But I'd say yes. I mean, he was a big man, or still is. Number 3 says Martin Scorsese is 63 inches tall. So we want to know. So this is going to be a negative z value because he's below the mean. So 63 minus 69 is negative 6. Negative 6 over 2.5 is, I don't know, is negative 2.4 as far as his z-score goes. Okay? So a negative score would be below the average. A positive z-score would be above the average. Pretty simple. All right, number 4, professional wrestler known as The Undertaker. They say that he already has a z-score of 4.4. So we know our z-score equation's this. So we said it was our observed minus our mean. So observed minus the mean over the standard deviation. So we know it's 4.4 here. We don't know what the observed value is. So I'm just going to make that a question mark. We said the mean was 69. We said the standard deviation was 2.5. So if we do this backwards, this is going to tell us what his actual height is. So remember Algebra 1, we have a denominator on one side. So I multiply both sides by the denominator. So 4.4 times 2.5. So that's 11 equals question mark minus 69. Add 69 to both sides. So this Undertaker was 80 inches tall. Wow. Hang on. Did I do that math right?
I think you messed up.
I,
A z-score of 6.4. That's what I got.
oh, okay. Hang on. Where do we mess up? 70. Oh, wait. Shaquille was here. 85. Oh. Yeah. 85 minus 69 is 16 divided by 2.5. Okay. There was my mistake. So that should have been a 6.4. Sorry about that. So Shaq Daddy is 6.4 standard deviations above the mean. I'm sorry. I didn't mean to make a mistake. I apologize. I tell you. I might as well just go home. And number 5, it says the rock star Prince, who unfortunately passed away too soon, he has a z-score of negative 2.8. So we're going to go negative 2.8 equals question mark minus 69 times 80. Or no, times 2.5. I'm making up values as I plug them in. So 2.8 times 2.5. Negative 2.5. That's like a negative 7, right? Question mark minus 69. Add 69 to that. So Prince was a whopping 62 inches tall. He's a shorty. He was a shorty. But you guys seen the movie Purple Rain? If any of you have liked any of Prince's music, I'm sure you've heard it. Yeah.
On the bottom of the equation, what is that right there? The negative what?
Negative 7 equals question mark minus 69. Right here, you talking about?
Yeah.
Yeah, negative 7 equals question mark minus 69 because we would have multiplied each side by 2.5. All right. Cool. So that's doing z-scores pretty simply on those. And then let's take a look at those. That says, let's assume something. The investment fund for a mean annual return rate of 10% with standard deviation of 4%. Ooh. Hey, 10% return on investments is good. You want to know how quickly money doubles at 10%? 7.2 years. Kid you not. Okay, so they said the mean return is 10%. standard deviation is 4. So let's draw a number line to show the 7 locations. Okay. So number 6, what we're going to do is this. A number line here, this is basically 10. And then this would be a z-score of 1, 2, and 3. That's a z-score of 0, -1, -2, -3. So this would be 14, 18, 22. And then the other way would be 6, 2, -2. Okay? So all I did is I either added or subtracted to get those z-scores. Okay? Huh. That'll work. All right. What was the z-score for 2011, which the annual return was 8%? Annual return's 8%. Okay. So again, we're going to use our z-score equation, which was the observed minus the mean over the standard deviation. So for number 7, they said 8%. So I have 8 minus 10 over 4, which is -2 over 4, which is -0.5 is the z-score. Okay. That's pretty simple algebra, I think, but I am the teacher, so. Of course, when I make an error, then I blame, other stuff, so that just makes me normal. All right, number 8 says, what was the z-score for 2008, which the annual return was 15%? Wow, 15% return, that's pretty good. All right, so again, my z-score, observed minus mean over standard deviation. So we have 15 minus, they said 10 over 4. So that's going to be 5 over 4. And then 5 divided by 4 is like 1.25. Okay, so it's above, it's 1.25 standard deviations above the average. And hopefully what I teach today is going to kind of start pulling some of these things more together. All right, what would a z-score of 0 represent? If I had a z-score of 0, that means that, yeah, so your mean is 10 and you're done. I mean, that's basically it. Your mean was exactly what your z-score was. So 0 z-score is right there on the axis. In which year was the z-score was -4.5, the annual investment return? Okay. So number 10, they say if you had a z-score of -4.5, so z-score is observed minus the average over standard deviation. And so I'm going to take -4.5, put that in for z. I don't know what my curly Q is, but this is for observed in the mind of stirrup, minus 10% over 4. So 4 times 4.5. Yeah, and that's -18, right? Equals this, minus 10. Add 10 to both sides. So do it, I had a, did I do that math right? Yeah. -8. Ooh. In a year in which the z-score was -4.5. Oh my gosh, you lost, your investment lost 8%. Yikes. As far as investment standpoints go, you don't want your investments to lose money. Just, cheap advice from Stirrup, but I'm here all day. Explain what a positive z-score represents in the context of this question. A positive z-score is above 10% interest. It's pretty simple. All right. So, money. We like money. All right, my friends. Everyone, any questions on that page? Whatever page we're on. All right, we got someone fishing at the Chatfield Reservoir. And he caught a fish at a Z-score of 1.2. Explain what this means in the context of the question. Well, if you have a Z-score of 1.2, that means you are 1.2 standard deviations above the average. Well, what was the average? I don't know. I'm pretty sure when you go fishing, you don't weigh things and it gives you Z-scores, but they're just pretending. And then 13, so a 1.2 Z-score is your 1.2 standard deviations above the mean. 13, James was fishing at Chatfield, caught a fish that weighs a Z-score of -3. Explain what that means. He caught a fish that was 3 standard deviations below the average. So it was a little tiny fish. And then in a fishing contest at Chatfield Reservoir, prizes are given to large fish caught of the 3 different types. Overall population, means of standard deviation for each kind of fish are shown. So you have bass, trout, and walleye, and they give mean weight standard deviation. Okay. So let's do some math. All right, so number 14, which is larger? So they said you have a bass of 6 or a walleye of 7. So which is larger for its type? Okay, so what we're going to do is we need to look at the bass. They have a mean for bass of 5.5, standard deviation of 1.2. So 6 minus 5.5 divided by 1.2. So 6 minus 5.5 is 0.5. 0.5 divided by 1.2. So this would have had a Z-score of 0.42. All right, well, that's above the average, which is good. And then the walleye, we have, they said the average of the walleye is 6.2. Standard deviation is 1.5. So I'm going to go 7 for a Z-score. 7 minus 6.2 divided by 1.5. So that's 0.8 divided by 1.5. So this has a Z-score of 0.53. All right, so the walleye is actually, your catch of the walleye was actually larger, you know, and you're like, well, Duster, one weighed 6 pounds, one weighed 7 pounds. It's like, but I'm comparing 2 different things. So, but you caught a bigger walleye than, your Z-score for your walleye was bigger than your bass, so it would have been a larger type. And which is larger relative type, a 4-pound rainbow trout or a 5-pound walleye? Okay, so 15. Let's see, you have a 4-pound rainbow versus a 5-pound walleye. All right, so a rainbow trout, they said was average was 4.7, standard deviation was 1. And then the walleye was 6.2. And standard deviation was, what am I looking at, walleye? 1.5. All right, so let's see who's bigger in this context. So the Z-score is going to be 4 minus 4.7 over 1.0. So the Z-score here comes out to negative 0.7. And then this one is going to be Z-score of 5 minus 6.2 divided by 1.5. Uh-oh, someone's bringing a Starbucks gift card. Who do we got? It's like, man, you keep harassing me every time I come in. It's not Starbucks gift cards. Oh, he's not here today. Thank you. Made you walk extra far. I'm sorry. So 5 minus 6.2 is negative 1.2. Divided by 1.5. So this guy has a Z-score of negative 0.8. So which one is further from 0? The walleye is. So the rainbow trout was bigger in the context of fish in this situation. All right, so Z-score is going to do a big comparison between lots of things. Last question says, you have that one intelligent friend, you know, the one you bring along so it makes you look smart. Point fingers. Just remember, when you're pointing fingers, You have three fingers that point back at you. Oh. All right. Hey, your friend takes a test and obtains a z-score of 0. Your friend says, I got a 0. That's awful. How do you explain that this score isn't so bad? Well, your friend got a z-score of 0. That just means, hey, your friend got the average score. Okay? The average score might be good, might be bad. I don't know. So, friends, do you have any questions about these things? So the quiz will be on, the test will be on Thursday. Longer period gives you better opportunity to learn stuff. But finally, I've been talking about this normal curve for like ever. So when you go to 3.2 in your books, your notes. All right. What is normal distribution? Okay, there's all kinds of things that create normal distributions. And then there's a lot of things that come close to normal distribution. What page is this for 3.32? Page 69? The average height of a male in the United States? Okay. All right. So normal distribution. So a few things to know. If you had a normal curve like this, you have an average here, and then you have a standard deviation going this way. And then you have subtracting the standard deviations going this way to get smaller. Okay, now those standard deviations are like z-scores, right? One of the big differences of a z-score versus a standard deviation, a z-score is basically from -4 to +4. A lot of times when you draw a normal curve in, if you said, oh, the average on a test is a 90, standard deviation of 5, you're adding 5 each time to your standard deviation. So to get the z-score, you convert it to a z-score, and it gives you a number from basically -4 to +4 for your score. And there's ways to go back and forth to figure out if you had a z-score of this, what was the actual score? If I had an actual score, what's the z-score? You go back and forth. So main thing about a normal curve, you have a peak at the center. The shape is symmetric, meaning you could fold it over the center and it would lie on top of itself. The curve approaches 0 as an asymptote, okay, on both sides. The curve will never intersect the x-axis. Okay, so the tails to the right and to the left will never cross the x-axis. They are asymptotes. The area under the curve is 100% or 1. Okay, so we're going to start analyzing to see if data falls into normal distribution, and then there's tests that we will learn later in this chapter to see if we do have some sort of normalcy. Now, things that we have done so far. We have done box plots. Agree? Okay, so things about a box plot, you know that 25% of your data fits in each one of these regions, right? Okay, now if you were to look at the distances of all these regions, that's one way to check for normalcy. Okay, if it's completely symmetric, meaning the rectangle on the left and the rectangle on the right, they are the same size, that's great. If the tails to the right and to the left are the same size, that's one way that we could say we could have a normal distribution. Okay, so is it possible, like let's say, let's see how artistic this guy can be. Okay, don't applaud, just throw money. What is that a really, really bad picture of? The U.S. And we're kind of missing the one state that kind of looks like this weird nose and has got this beard and then comes back in and it's like, way big. And then I got this other state over here that's got some islands to it. And then we have territories, in different places. You may be down here in Samoa, things like that. So basically you have this region. Okay. Within this region, you have lots of people. Now, there are some places some places in the United States that have more people than others. And usually, you know, regions like New York City, Los Angeles, Chicago, okay? You know, Denver's pretty big. Yeah, Phoenix over here. Maybe that's almost New Mexico, but let's pretend I can draw really well. You know, you Dallas, Fort Worth, and all that. So you have some populations that are big. You know, you have Seattle up here. It's closer to the ocean. Then state of Washington, maybe San Francisco, Sacramento. So you have these populous things. So we have been subjected to hearing and seeing and having all these types of commercials. And then some of these commercials talk about this is what polls are showing. So let me ask you, friends, if I were to go to New York City, and if I were to find 500 random people and say, are you voting for chocolate ice cream or vanilla ice cream? Or if you're voting for Pepsi versus Coke. I'm not trying to go with any candidates on here. Okay? Are you going to trust that poll for New York City to represent the rest of the United States? I mean, it's a big population, isn't it? You know, like 30-some million people. Do you trust the poll from New York City to represent all the rest of the United States? The really bad, but somewhat okay-looking graph stirred through. Do you trust this? Do you want New York City dictating what you think? No. So you have been subjected to all these polls. And they'll say, hey, a poll here says this, a poll here says this, a poll here says this, there's a poll over here that says this, a poll over here says this. We actually did a poll of a bunch of dolphins and then found some sea lions. I don't even know if sea lions are over there, but let's just pretend. Like, they are collecting data on a poll from people, and then they're saying this is what this poll showed, but they aren't contacting the rest of the United States. Have any of you gotten a text message saying who are you voting for, or a political call that you just ignored? No? You guys got lucky. If you haven't, what phone service are you using? Because I want that phone service. I mean, I kid you not, I got a thing yesterday that said if I donate $5 more to this candidate is guaranteed to win. I had no idea that $5 had that big of an impact. But I didn't donate $5. Not because it wasn't my candidate or not, but I'm like, this is ridiculous. I think that right now is a time for the biggest scams to be taking place on this. I mean, could you imagine? We're politically divided. 50% like, 50% hate. Okay? Either candidate. I can't figure out the undecided voter at this point. Because I'm not sure what a political candidate, like a guy's going, you know what, I'm going to wait till about 6 o'clock tonight before I go to the polls and actually vote in person. You haven't figured out who you're voting for yet? Nah, I still haven't decided. Like, I don't ever want to hang out with that person and, like, go to a restaurant. Do you need a few more minutes with the menu? Yeah, I'm undecided. You know, 4 hours later and 18 bowls of chips and salsa that I've ingested later, have you figured this out? Well, I'm kind of wavering between this and this. Get them both. I'll buy you both. Can we just order? So, I don't know. But let's see. This normal curve, it's tough to collect data from 100%, though every 10 years the United States does something called the census, and the census is to try and capture 100% of the population of the United States and their territories to figure out certain things. And it's funny because anytime the census comes rolling around, people will say, they don't have the right to ask me that. Well, the last census that came out is like, how many cars does your household have? Like, I'm pretty sure they could just go to DMV and figure out that information. People are like, they have no right to know how many cars I have in my house. who cares? They have no right to ask me how many television sets I have in my house. They have no right to ask me how many faucets are in my house. I mean, like, these are some things that were on the census, which was kind of goofy. And you get these people that claim that their rights are being violated because they're asking how many toilets are in their house. And I'm like, I kid you not, there's some silly stuff on these census. And they want you to fill out the census. And if you don't fill it out, they kind of try and get a hold of you to find out. It's actually a very costly measure, but a census is 100% of the population contributing to it. Whereas if you have 100% that contribute to it, you don't have a margin of error. Bless you. So a census is one thing, but when we are dealing with a normal curve is a different thing. Stirrups on the move again. Watch your toes. Watch your fingers. Watch your shoelaces. Ooh, man, I snag a shoelace and go wah, wah, wah. All right. So what else does it say? So then we come down to this bell curve. Now, have any of you watched Price is Right? You know the show I'm talking about? There's a game on Price is Right called Plinko. And how Plinko works is you win this little disc, and then at the bottom of the Plinko board, they have money values. Okay? Now, I kid you not. In the world of Plinko, basically they have down here, I don't know, they have, let's see, 1, 2, 3, 4, 5, 6, makes 7. So the very middle is big money. And then you have a 0 here and a 0 here. And then you have like 1,000 here and 1,000 here. And then you have like 500 here and 500 here. And you have these basically these nails that are in a board. I don't know if they're actually nails, but it's some sort of device to kind of, they are offset. And what you do is you're at the very top of this and you drop this disc down, and this disc is going to come down through these things as it bounces. Now, people are all over the place with Plinko. Honestly, the best place for them to drop the puck, the little chip, is right directly over this, because this is the most likely region for your Plinko chip to hit. But people are afraid of it because you have 0 on either side, so they try and play it safe, so they push the Plinko chip down here to get over here to guarantee 1,000 or 500. Well, this might be 25,000. So if they got like 5 chips in there, 25,000 times 5, it's like $1 million. Like Sturby did the math wrong. But I kid you not, like on the game show Price is Right, if you ever watch it, if you ever see the game Plinko, it's something to go with. Okay, what time we out of here? 10:06. I think I've done enough damage for today. When is our quiz? Our test? Thursday. Okay, so we'll continue this tomorrow.